Welcome back. In this video, we will solve systems of equations by graphing. So the first step to that is to graph each function. So let's do that here. So we have y equals negative 3x plus 1. That's a y-intercept of 1. And a slope of negative 3. That's down 3 and right 1 as many times as we can. And up 3 and left 1. So here is the graph of the first function. The second function, let's do this from this form instead of changing it to slope-intercept form. We'll just do a quick t-chart here with a 0 for x and a 0 for y. So we'll find the x and y intercepts. So if x is 0, then this is 0 minus y equals 4. So we've got negative y equals 4, which means y is negative 4. So 0, negative 4. Well, I need to go one more, so there it is. And if I put in a 0 for y, then it's 2x minus 0 equals 4. So 2x equals 4, divide by 2, and I get x is 2. So the x-intercept is 2, that's 2, 0. So the slope would be up 4, right 2, which simplifies to up 2, right 1. And down 2, left 1, and there is the line. So there's step 1, graph each function. Step 2, find the point or points of intersection. Right there is my point of intersection, and that is at 1, negative 2. So the solution is the point of intersection, and that is 1, negative 2. Okay, next we have another line in standard form. So we'll do a t-chart and find the x and y intercepts. So if I put in a 0 for x, I get negative 3y equals 6, and I can divide and get y is negative 2. So 0, negative 2 is my y-intercept. Put in a 0 for y, and I get 2x equals 6. Divide by 2, and I get x is 3. So 3, 0. Okay, so that's going up 2, right 3, so we'll continue that. And down 2, left 3. Okay, so there's the first graph. The second graph has a y-intercept of 1 and a slope of 2/3, up 2, right 3. And down 2, left 3. Now notice that these have the same slope of 2/3. And what we've graphed here is a pair of parallel lines. There is no intersection, which means there is no solution. The solution is the point or the points of intersection, and there are no points of intersection. Okay, next we've got a line in standard form. So if I put in a 0 for x, I get negative 2y equals 2. So y is negative 1. So that's 0, negative 1. And put in a 0 for y, and I'll get 2 over 6, or 1/3. And that's going to be kind of hard to graph, so let's just go ahead and change this one to slope-intercept form. So if I was just to switch these, I would get 6x minus 2 equals 2y, and divide everything by 2, and I'll get 3x minus 1 equals y. So I've got a y-intercept of negative 1, which is what I got here, and then a slope of 3, so up 3, right 1, and down 3, left 1. So there's the graph of the first function. Now the next one looks like the same line, doesn't it? Y equals 3x minus 1. We've got a y-intercept of negative 1, a slope of 3. So it's going to fall on exactly the same line, which means that there's an infinite number of points of intersection, so there's an infinite number of solutions. Next, I've got an absolute value and a line. So the absolute value is going to have a vertex at positive 4, 2, right 4, up 2, and it's going to have a slope on the right side of 1, which means the slope on the left side is negative 1. Okay, so there's the first function. The second function has a y-intercept at negative 1 and a slope of 2. And usually I like to fill the graph, but I'm going to be able to see everything I need here. There's the point of intersection, and it's not on an integer point. So let's move on. We'll come back to this and use a graphing calculator to find out that exact location. But this is the one downside to solving by graphing. If it's not on an integer set of coordinates, it's difficult to know without having a graphing calculator exactly what that intersection is. So there are other ways to do it, but solving by graphing, there's our downfall. So let's go over to number 5, and then we'll come back with a graphing calculator to do number 4. So y equals x squared minus 4x, that's going to be a parabola. So we'll make a t-chart. So if x is 0, I've got 0 minus 0 is 0. If x is 1, that's 1 minus 4, that's negative 3. If x is 2, that's 4 minus 8, which is negative 4. If x is 3, that's 9 minus 12, negative 3. If x is 4, that's 16 minus 16, which is 0. If x is 5, that would be 25 minus 20, which is 5. Well, let's go back the other direction. We'll put in a negative 1. So that would be 1 minus negative 4, which is 5. Negative 1, 5. And that's going to give me the full picture of this parabola. Okay, so there's the parabola. Next we have a line with a y-intercept of negative 2. And a slope of negative 1/3, that's down 1 and right 3. Let's go one more the other way, up 1 and left 3. Okay, so here is the line. Now this one's going to have two solutions, one here and one here. This one right here is 3, negative 3. That one's easy to see. So 3, negative 3. But we've got a non-integer coordinate right here. So we're going to have to use the same skill we apply here to number 4 to figure out that point of intersection. So on our calculator, we'll go to y equals, and we'll type in the equations. Now to get absolute value, we will hit the math button and number in option 1, absolute value. And inside the absolute value, we will type in x minus 4. And we'll get outside the absolute value plus 2. And for y2, we'll graph the line 2x minus 1 and graph. And we can see our point of intersection right there. So we need to calculate that point of intersection. So we're going to choose second and calculate. Option 5, a point of intersection. Okay, so it's going to put a cursor on this first, on y1, we'll hit enter, and then now we're on y2, we'll hit enter, and it's going to tell us the point of intersection at the closest point of intersection. Now there's only one point of intersection, so that's perfect. So one more enter, and there it is, 2.3 repeating, 3.6 repeating. So that's 2 and 1/3, 3 and 2/3. Okay, then our next line, y equals clear, clear, and x squared minus 4x, and negative 1/3 x minus 2, and graph. And we can see 2 points of intersection here and here. Now let's get this one first. We know this one. So we'll hit trace and take this cursor over here closer to this point of intersection. And we'll hit second calc option 5 and first curve, second curve. And now it's going to give us the one closest to that point that I'm on right now. And that is 3, -3, just like we thought. So then, let's take that cursor closer to the other point of intersection. And second, calculate. And intersection. Here's where we actually need to move this over. We'll go closer to that one. Enter, enter. Now get the closest one. And there it is. 0.6 repeating. -2.2 repeating. So 0.6 repeating is 2/3. -2.2 repeating is -2. And you could put 0.2 with a bar over it. As a fraction, it's 2/9. There's -2.2 repeating. So there are the 2 points of intersection. So those are the two solutions.